Let us start today the second topic from Science and Technology, class 9th, is work and energy. We are today discussing about the first part of this chapter for 9th standard, that is work and energy. This chapter includes the concept of work, the concept of energy, the mechanical energy, law of conservation of energy, and free fall. We will see one by one what are these concepts and what are their significance. Look at this picture. The girl is sitting, the boy is walking, another girl is watching the television while a laborer is taking some load on his neck and he is walking. Observe clearly. The first picture that we observed is a girl is sitting and she is reading the book as well as writing on the paper. The second picture is the boy is walking on the ground. It means he is moving from one place to the another. The third picture that we have seen, that a girl is sitting in front of a television and she is watching some picture. Well, the fourth picture that we have seen is that one laborer is taking one sack on his neck and he is walking for certain distance. Now in these four pictures we have seen that there are two pictures in which someone is sitting. In the first picture that we will see, in the first picture this girl is sitting as well as this girl is sitting. Both these two, they are not moving in any position. While the second picture in which the boy is walking, as well as in the fourth picture the person is also walking with some luggage. So it means in two things the work is done, while in another two things the work is not done. What is the definition of work? When a force is applied and the object is displaced from its position, then and then only, according to science, the work is done. Actually, when we think about any type of work, it may be mental or it may be physical. But in science, what is work? When the force is applied on the object and if the object is displaced, we can say that the work is done. Means in the previous examples, only the boy and the porter, that is the coolie or the laborer, has done work. While two girls which are sitting only, they are not performing their work because they are not displacing at all. It means mathematically the work is given as work is equal to force into displacement, where force is a vector as well as the displacement is a vector. But remember, work is not a vector, because when we calculate the work will be calculated by the product of magnitudes of force and displacement only. No directions are considered, and that's why vector is always considered as a scalar quantity. You have learned in the previous year that how to calculate the work done on an object when the displacement is in the direction of the applied force. But if the displacement is not in the direction of the applied force, how do we can calculate the amount of work? Let us recall once again. See here. One girl is sitting in front of a table. In her right hand there is an object and she is applying a force, and due to that force now the object is moving from A to B. Are you getting this point? She is applying the force by the right hand in this direction and the object is displaced from position A to B. It means the object is displacing in the direction of the force which the girl is applying. If suppose the force applied and the displacement of the direction both are in the same, then in that case the work can be calculated by a simple formula. We have seen that in the previous year also. What is that formula? See once again the picture. Suppose the object is at position E, and now if F is the force applied, and by applying the force, if the object is displaced, what is S? It is the displacement. The object is coming from A to B. In that case, the work can be calculated by the formula W is equal to F into S, where we are writing the simple formula, that is W is equal to F into S, because the applied force and the displacement both are in the same directions, and that's why they are not making any angle, and that's why the work can be calculated by the simple formula W is equal to F into S. Now look at these two pictures. These two are very interesting pictures. In the picture B, a girl is pulling a toy. एक गाडी आहे, त्या गाडीला एक दोरी बांधलेली आहे आणि ही छोटी मुलगी त्या गाडीला ओढते आहे. सी केअरफुली. गाडी ज्या दिशेला जायला पाहिजे त्या सरळ दिशेला ही दोरी दिसत नाही आपल्याला. इट इज स्लाइटली इन्क्लाइंड. ही थोडीशी तिरकस दिसते आहे. See here, this is the direction of force through which the girl is pulling that toy, while the toy is moving in the forward direction. The direction of the toy is different and the force applied is different, and that's why the direction of the force and the direction of the movement of toy, they are having slightly inclined direction or inclined position. Look the third picture. In this picture you will find that one car is towing another car. समोरची गाडी मागच्या गाडीला पुढे खेचते आहे. ही खेचण्याची जी डायरेक्शन आहे ती डायरेक्शन एका ठराविक अँगलने आहे. If suppose we are discussing about the direction of the pulling and the direction of the movement of the car, they are making certain angle. B आणि C या दोन्ही पिक्चर मध्ये तुमच्या लक्षात येईल, the displacement of object is in one direction while the direction of force is making certain angle. It is inclined. Then this type of picture is there. आता या पिक्चर मध्ये तुमच्या लक्षात येईल, this is the direction of force. बल या दिशेला आहे. मुलगी तिरकस ओढते आहे त्या टॉयला आणि ते टॉय मात्र असं या दिशेला जात आहे. What does it indicate? This is the direction of force, while this is the direction of displacement of the object. Under this condition, an angle is developed. Look in this picture. या पिक्चर मध्ये तुमच्या लक्षात येईल, this is the direction of the force, while this is the direction of the displacement. An angle is made in between these two. We can say it as theta. म्हणजे विस्थापनाची दिशा आणि बलाची दिशा या एकच नसून या दोघांमध्ये थोडासा कोन आहे, थोडासा डिस्टन्स आहे, आणि त्यावेळेला व्हॉट इज द अँगल बिटवीन दीज टू, दॅट इज सपोज डिसिग्नेटेड ॲज थीटा. देन नाव द इक्वेशन चेंजेस. आता हे इक्वेशन कसं बनतंय बघा. हिअर नाव F1 दॅट इज द फोर्स अप्लाइड हिअर, म्हणजे या दिशेला जाणारं बल F1 म्हणू आपण, आणि हे ऍक्च्युअल बल आहे F. तर या F1 ची किंमत कशी दिली जाते? F1 is given as F1 is equal to F cos theta, where what is cos theta? Cos theta is equal to base upon hypotenuse. मग या ठिकाणी now the equation of work is changing. W is equal to F cos theta into S, where now cos theta is the angle which is made in between the directions of force and the direction of displacement, while S is the displacement. So this is another equation which is made or which is obtained for the calculation of work when the displacement is not taking place in the direction of force, it is slightly inclined. आता या ठिकाणी displacement of direction and the applied force direction, त्या दोघांमध्ये कोणता अँगल आहे त्यानुसार सुद्धा वर्कचे तीन प्रकार पडतात. सपोज देर इज नो एनी difference between the direction of force and the direction of displacement, means both are in the same direction. Then in that case, what is the cos theta? Theta ची व्हॅल्यू 0 आहे. मग cos 0 ची व्हॅल्यू किती? 1. म्हणून हे इक्वेशन काय बनतं? W is equal to F into S. cos theta राहणारच नाही, कारण तिची व्हॅल्यू आता 1 आहे. Then in that case, this work is said to be positive work. म्हणजे जर समजा displacement of force and the direction of force are same, then in that case the work is positive. दुसरी कंडिशन बघूया आपण. If the displacement is taking place exactly 90 angle, जर 90 अंशामध्ये तयार होत आहे, cos 90, थिटाची किंमत जर cos 90 असेल, then in that case it will be like that. Then in that case you will find that if suppose cos 90 is 0, then in that case W is equal to 0. Then that work is said to be 0 work done. आणि जर समजा applied force च्या अगदी विरुद्ध दिशेला पदार्थ जातो आहे, then in that case the direction between these two forces is 180, or angle between these two forces is 180. Then in that case cos 180 is equal to -1, and then W is equal to -F into S. It means the work done is now negative. Such type of positive, zero work and negative work can be calculated. Now we will proceed further towards another part. What is the relation between joule and erg? हे पाहण्यापूर्वी आपण हे बघूया, what is the unit of work? वर्कचा फॉर्म्युला काय? वर्क इज इक्वल टू फोर्स इंटू डिस्प्लेसमेंट. Force is measured in Newton. Then displacement is measured in meter. Under this condition, what should be the formula? Work should be equal to, or work can be measured in what? Newton meter. But in the honor of, or in the memory of joule, the work done is measured in another unit, that is joule. Work is equal to force into displacement. It should be measured in Newton meter. The unit of work should be Newton meter. But in the honor of joule, in MKS, it is taken as joule. What is 1 joule then? 1 joule is equal to 1 Newton into 1 meter. बघा याच फॉर्म्युलामध्ये बघा. If the force is measured in Newton, displacement is meter, then in that case, if 1 joule is equal to 1 Newton into 1 meter, याचा अर्थ, if by applying 1 Newton force, if the object is displaced by 1 meter, then the work done is taken as 1 joule. 1 न्यूटन बलाने पदार्थाचे 1 मीटर विस्थापन होत असेल, तर अशा वेळेला झालेलं कार्य 1 जूल मानलं जातं. While in CGS, the unit of work is erg. काय रिलेशन आहे दोघांमध्ये आपण बघूया. See, this is the relation between joule and erg. पुन्हा एकदा बघूया. वर्क इज इक्वल टू फोर्स इंटू डिस्प्लेसमेंट. 1 joule is equal to 1 Newton into 1 meter. आता what is 1 Newton? It is 10 to the power 5 dyne. आपण हे पहिल्या चॅप्टर मध्ये शिकलो. While what is 1 meter? It is 10 to the power 2 centimeter. आपल्याला माहिती 1 मीटर बरोबर 100 सेंटीमीटर, means 10 to the power 2 centimeter. So 1 joule is equal to 10 to the power 7 dyne centimeter. याचाच अर्थ 1 joule बरोबर 10⁷ अर्ग. Erg is the unit for the measurement of work in CGS. 1 erg is equal to 1 dyne into 1 centimeter. बघा 1 joule is equal to 1 Newton into 1 meter. 1 erg is equal to 1 dyne into 1 centimeter. हे भाई AM केस मध्ये, हे CGS मध्ये. These are the relationship between joule and erg, and we can measure the work done in joule in case of MKS, while in erg in case of CGS. So this is all about the first part of work and energy. Thank you.